Welcome. Today we're going to be going through integers x and y such that the square root of x plus the square root of y, so you have the square root of x plus the square root of y, and they told us it is equal to 16 plus the square root of, that's root 240. So you have root x plus root y squared is equal to 16 plus the square root of 240. All right. Now, if you're to expand this square, it's going to be first term square. So you get x plus twice the product of the 2. It's going to become 2 times the root of x times y plus the second term square plus the root of y squared, which is y. And that's going to be equal to 16 plus, to break down the square root of 240, I can rewrite it as the square root of, I'm going to use 4 times the square root of 60. All right, nice. Now I noticed that I have something right here without square root on the left and something with square root, and on the over here too I have something with square root and without square root. So I'm just going to group them together as x plus y. So I'm grouping the terms without square root, x plus y plus 2 times the root of xy, and that is equal to 16 plus the square root of 4 is 2 times the root of 60. Nice and easy. Now look at this now. If two things are equal to each other, if x plus y plus 2 root xy is equal to 16 plus 2 root 60, then what is that telling me? That is then telling me that x plus y must be equal to 16, and that is also telling me that 2 root xy must be equal to 2 root 60. So that's how I'm going to solve for x and y. So if x plus y is equal to 16, and then from this it's telling me that 2 times the square root of xy is equal to 2 times the square root of 60. That's what that is telling me. Now if 2 times the square root of xy is equal to 2 times the square root of 60, then really and truly the next equation they're getting at is just that x times y is equal to 60. Nice. Now if x plus y is 16 and x times y is 60, the only possible solutions are x equal 10, y equal 6, or y equal 6 and x equal, or x equals 6 and y equal 10. 10 plus 16 is 16, and 10 times 6 is 60. So that's the only solution. Let's write that down. So the solution, so the solutions are going to be x is equal to 6 and y is equal to 10. That's one possibility. Or the next solution is x equal to 10 and y equal to 6. Too easy, soft. And that takes care of part B. So you see what is nice? Nothing too stressful so far. Nice and easy. Now let's go ahead now, and we are going to look at the next portion of the question, which is part C. Now part C, it says that solve for real values of x the inequality where they give us the modulus of 3x minus 7 is less than or equal to 5. Now, if the modulus of 3x minus 7 is less than or equal to 5, then what we do then is, what this is telling us then is that 3x minus 7 is going to be less than or equal to 5, but greater than or equal to negative 5. We can then add 7 to both sides to get that 3x is going to be less than or equal to, adding 7 to this side, you get 12. Adding 7 to this side, 7 minus 5, I believe that is 2. 7 minus 5 is 2. Then you divide through by 3 to get that x is going to be less than or equal to 4, but greater than or equal to 2 divided by 3. All right, so that is the solution for this question. Nice. So that's that. Now part 2. This is part 1. Now let's have a look at part 2. Part 2, it is saying that show that no real solution for x exists for the inequality. The modulus of 3x minus 7 plus 5 is less than or equal to 0. So the modulus of 3x minus 7 plus 5 is less than or equal to 0. Show that this has no solution. Now to show that this has no solution, all you have to do is subtract 5 from both sides and you're going to get the norm of, or the modulus of 3x minus 7, and you're going to get that that is less than or equal to negative 5. All right, but we know that modulus cannot be negative, so you can write that, but you can tell them, but the mod of a, all right, where a is some real number, is always greater, the mod of a is always greater than or equal to 0. So hence, the modulus of 3x minus 7, the modulus of 3x minus 7 can never be less than 0. All right, so hence that has no solution. Finally, hence the norm of 3x minus 7, modulus of that being less than or equal to 0, this has no solution. Oh, this shouldn't be 0. This shouldn't be 0. This should be minus 5. Minus 5 has no solution. So that's the real reason, because we know modulus cannot be negative. So this has no solution. I'm going to write no sol, which means no solution. Nice and easy, and that takes care of question 1. Easy, 25 marks. Let's have a crack at question 2. Question 2 says,